Hey there, this is part 2 of the video series regarding on how to create rock formations for your environment. So in the previous part what we did was create a high poly mesh by putting together a bunch of rock models in 3D Code. So we've finished doing the high poly mesh, and we've exported this same mesh into two different versions. One which is the high poly for creating and rendering the normal map and ambient occlusion, while the other one is slowly exported for creating a low poly mesh for real-time applications such as Cryengine or UDK. So in order to create the low poly mesh, we have to run this medium resolution mesh through some filters. The filter question is a decimation filter, which will allow us to lower down the poly count on our medium resolution mesh. The application that we're going to use is a free application called Meshlab. You can find it on their website. You could just Google up Meshlab and download it from meshlab.sourceforge.net. In my case, I'm using a fairly old version. It is a 1.2.3 version. I didn't bother updating the application, even though I should. But you can download it from that website, and it is supposed. I think it is pretty much the exact same thing, even though the version is different. You might get some extra features and extra menus showing up. But anyways, now the goal here is to import the medium resolution mesh, which is supposed to be at 500,000 polygons. So if you remember correctly, we exported this mesh here into a folder which is on my desk here, and I called it rock underscore 01 underscore 3dc, that stands for 3D code underscore mp, that stands for medium poly dot obj. So just click on the icon here and browse all the way to the where you exported the folder and open it up. Now you get the mesh showing up here. Just clicking on the interface on this window here allows you to rotate around and check out the medium poly mesh. Now in order to decimate this mesh, you have to go through filters, remeshing, simplification, and reconstruction, and then click on quadric edge collapse decimation. You got a window that shows up. Let's change the quality threshold to 1, and then you get two options. You could either lower down the poly count of your mesh that shows up here, the amount of faces, by percentage, which is from 0 to 1. If you type in a 0.5, you remove 50% of the total poly count on the medium poly mesh, or you could just type in an exact value for the target, the number of faces. In this case, I have 250,000 faces. So I'll use around 800 faces, 800 polys. Actually, it's going to be in triangles. And once you're done typing the value that you want, the desired value, you just hit on apply, and you wait for it to process and decimate the mesh. And then once it's done, just hit on close and turn on this flat lines viewport and option, and you can examine your low poly mesh. If you're not happy with the result, you can always reopen the medium poly mesh and redo the decimation with different values. So right here we got 800 faces, sorry, and I think that this is a pretty good value. It has a good compromise between quality and performance. Once you're doing the low poly mesh, you always need to keep an eye on the silhouette and try to make this silhouette look as smooth as possible, and avoid having it look too low poly. But anyways, once we're done decimating the mesh and generating the low poly mesh, all you have to do then is just go to File, Save As, and save it in the same rock underscore tutorial folder, and we'll just name it underscore LP, that stands for low poly, and save it. Make sure that you select OBJ file format while saving. There it is. Or what you could do is just do a dot OBJ and it will save it as an OBJ. You got these options that show up. The normals, this is really not important anymore anyways, because we'll be remaking the normals for the low poly mesh in Maya. Color, I'm guessing this is for vertex colors. Just leave the option as they are, the way they are, and press on OK. Now we've saved the low poly mesh. And what we're going to do now is import this low poly mesh that we did in Meshlab and create UVs for it and set it up for texturing and rendering texture maps. So browse all the way to where you exported the low poly mesh and import it in Maya. Turn on shaded polys, and we have here our low poly mesh. Assign it a material to it. I'll assign a Lambert material instead of using the one that comes with the OBJ file. And before we do any UV work and tweaking the mesh, we need to run this through a cleanup filter. That way we can make sure that the mesh doesn't have any problem or non-manifold geometry in it, just in case. So in Maya, in order to do that, you just go to Mesh menu and click on Cleanup. So I'm using the default options. I just, instead of clean matching polygons, do select matching polygons. That way you can manually examine which part is problematic on your mesh. And once you hit apply, if it selects some areas, they'll be shown in red. That means that there are some problematic areas that you need to fix, delete, or remake. But if it deselects the mesh, once I select it and click apply, that means that the mesh doesn't have any problems and it is clean, ready to use. So once you're done doing the cleanup process, you can first create a basic UV for it. I'm just gonna do a planar mapping projection on it. Now this is done. And make sure, go to edge selection and make sure that all your edges are welded. This is Sue edges. I mean, if I had an edge that was opened up on my viewport, it would look like this. But by default in Maya, you don't have this option on. So in order to turn this option on whenever you create a seam on your UVs that shows up in your 3D viewport, you'll have to change some settings. So in order to do that, go to Windows, Settings, and Preferences, and then go to Polygons. Let me check where it is. There you go. You go to Polygons in this under Display. Check the texture borders. This value here, the edge width, is supposed to be, by default, is set to 2.0. Set it to 4.0. Then save and close Maya and reopen it again, because these settings won't apply until you relaunch Maya. I'm not sure if it's the case in Maya 2011 and higher, but you'll have to rerun Maya just to make sure that your settings have been applied. If you want to set up the way you have like the split and merge sew and cut edges on your shelf bar, you could create these buttons very simply. You have the merge UVs, or actually split UVs here. You just press on Control Shift and click here. Actually, it's not the same. Sorry. even though the name's kind of. So you got a merge UVs here. Never mind. What was the name again? Cut UV edges. Sorry. There it is. So you press, while pressing on your keyboard on Control Shift, you just click here and it will create a button for you. In my case, it all has already been done. It's over here, and then there's the Sue UV edges. There it is. So these are the two important tools that you want to add. For UVing, since I told you in the introduction video that I won't really be covering the UV techniques, but at least I'll show you the method that I use. Where do I cut the edges, and why do I put them over there, the seams for UVs? So usually when you're dealing with an organic model like this, you obviously have a very complex mesh, and it could be problematic when you try to make the UVs for such a mesh. The goal here is to put your seams in the cracks of the rocks, where the ambient occlusion is going to be very pronounced, and where the areas, in the dark areas, in a way where you can just hide the seams when you bring your mesh in the game engine, and the seams won't be that noticeable for the player when he looks at the asset. So in order to place these seams strategically, I'd say, you first want to help yourself by setting up the normals of the mesh in a way that will show you where the mesh has a curvature that allows you where you want to put the seam. In this case, you could obviously see that there's like two parts where there are two rocks that have been merged together. You can kind of guess, and you can kind of guess where the seam would be. But it could be difficult in this case because the shading doesn't really help us. So you probably want to recreate normals for this. So in order to do that, is go to normals here. Click on unlock normals first. This you'll have face it. The normals haven't been set up. Each face has its own. I'll say its own. It's set to hard edged. So you go to set normal angle and turn the value to 45 degrees and hit apply. And now you can kind of guess. It should be really easy where you want to put the seam for while making your UVs. In this case, for example, I'll probably go to edge selection and select create a seam where the shading shows a difference in the cracks between the rocks. Okay, but before we start cutting and creating the UVs, we probably want to set up the edge selection modes to camera based selection. That way, if I do a selection like this, it won't select what's in the back. And if I, for example, I'm trying to select here and then click here, and by accident it will select whatever you have in the back, and if you cut, it's going to cut also what's been selected in the back. So you want to set your selection mode to be a camera based selection. In order to do that, you go again to your settings and preferences. You go to preferences and go to selection here, over here, and turn on camera based selection, and then save the settings. Now if I do a selection, it'll only select where the camera is facing. It won't select what you have in the back. That way you'll avoid having any problems when you cut create the seams for your UVs. Now if I took a look at the UV window, well, we applied a planar projection. Every and single edge is merged together. This is at the moment is unusable for texturing. So we'll start cutting the parts and start unfolding. But keep in mind that in my case I'm using Roadkill. It is a Roadkill UV. I'm using the professional version. It is a plugin. There is a free version available that you could get. If you want to know, you just Google up Roadkill, and over here you can find a tool if you want. Now, I like using these plugins because really the tools that come with Maya for UVing, creating UVs and unfolding UVs, especially for making organic models, I really found them lacking. You got different alternatives. There's also the Maya bonus tools, which is free, and you can find them on the uh, website. It is an official Autodesk website, and you just Google up Maya bonus tools, and you can find a plugin which gives you access to advanced UV tools, and it is a really good alternative to the tools that come by default with Maya. So you do get the UV editing and some extra tools for modeling, animations, and etc. I'd suggest to use this if you don't have the money to buy the plugin that I'm currently using, which is Roadkill. But the goal here is really to show you why you want to you want to cut and create schemes in different areas, and how you want to organize your UVs in the how do you want to set up your UV layouts. So Maya bonus tools is really good alternative, and it is a free alternative for you if you want to have access to advanced UVing tools. There are multiple other scripts and plugins, free plugins that you can find on the internet, and as well on the area where you have access to a full database of plugins and scripts. Anyways, I'll close Meshlab here, and what I'm going to do here is start cutting down the edges. So, like I said, I want to create seams where it helps me hide them when later on I render out the ambient occlusion, and the seams will be hidden in these parts where it create these cracks here. So all I'm going to do here is just select the edges by holding shift and select them. This is where the seam is going to be, and then later on, once I'm done selecting and when I'm happy with the result, I just click here on the scissors icon to create a cut. Always important to check your mesh and try to guess where your seam is going to be. That way it makes it easier for you. So I'm first going to start to cut down the mesh by 2 in half. Sometimes it might be hard to guess which flow of edge you want to follow. So if it's hard for you to guess, you could just, if this part here is kind of difficult, you could just start where it obviously where it obviously needs to be cut. So instead of trying to guess which flow or which road my edge is going to take here, I could like start putting some cuts over here. Probably put a cut over here. And go ahead and put some cuts here in the cracks. Stop this one here. Probably create another part here. I'll link this here. Now once you're done like selecting the edges, you could just cut, and you can see that there's actually a seam that has been created. So what I'm gonna run now is I got the RG and RO. So if you're using roadkill, this stands, if you go to edit, you get roadkill geometric and roadkill organic. These are two different algorithms for unfolding your UVs. So it automatically does the job for you, and it is extremely fast. That's why I like using roadkill. So since we're dealing here with an organic asset, I'm just gonna click on RO for roadkill organic, and if I check the UV editor, I can see that it has been unfolded. But sometimes when you look here, you could probably like, hey, I'm just gonna cut this over here. I'm just like this edge here, and see exactly what it takes me. And yes, I missed this edge, so I'm just gonna cut this and click RO, and it's gonna unfold this again. But before we go any further, the roadkill comes with a shader that allows you to see where the stretching happens. You really want to have uniform textile density all over your mesh. That way, the texture isn't too blurred or too sharp, and in some areas of the same asset. And that will help you to get really good looking texture and really higher quality texturing on your mesh. So you just right click, assign new material, and select the roadkill stretch shader. Turn on texturing, and now you can see where the problematic parts are. While I'm using roadkill, the green parts are the normal parts where the textile density is normal. The blue ones shows you where the textile density is higher than it should be, while the red parts shows where the textile density is very low, and this is where the blurring is going to be, the blur is going to occur. So you really want to have a mesh that's going to end up to be generally green. That will show up when you apply the shader. So in order to fix this issue, we're going to have to create more seams and re-unfold it by using the RO button. So I'll reassign again the Lambert shader that I used earlier, because I find it easier to see where the shading is different, and I'll start creating more cuts. I'll just cut this over here. Now we could probably like create a whole UV island. I don't know how you call it for 3D CG Max, but we could probably like cut this part out and have it set up in DV differently. I'll disable the grid. Then selecting all the edges, cut again. I'll run this through the algorithm again. Just check out quickly the UV layout. Now we could probably cut this part here, because really when you create your UVs, you need also to keep in mind that you want to optimize your UVs in a way where you can fill out the whole square here, the whole area, the UV space. That way you can have, you take advantage of your texture that you're going to use, your square texture. So you have to, there's a lot of thinking and puzzle solving when you're creating your UVs. So in this case, I have this part here. This really doesn't help if I want to fill the whole space of my the whole UV space. So it would be maybe more interesting if I cut this part out. That way it will allow me to scale maybe this huge chunk here and have this part here like placed to fill in a gap or the spaces between the UV islands. So before I cut, maybe I'll just select the edge here in the UV window, and then hit F and see where the cut is supposed to be. And I think it could be a good choice to put this UV seam over here. If I run this again to RO, and there you go, it's been detached. So we're going to have to examine the mesh again and see where we can create more seams. But we might as well detach this part here, this whole chunk. Always try to guess the best flow to follow for your UV seams. This is really important, that way you can have proper texturing and always try to hide and guess where the different parts of your high poly model are linked together. Could probably do cut again here for this one. Because we really want to avoid to put the whole UV and have parts like these that stand out too much, and it will create lots of distortion on your UV and your texture. I'm guessing this is good. We can cut this as well. This part here could be problematic over here. I can already kind of guess that there will be kind of lots of stretching, so I'll have to cut this as if it was a cube that I'm unfolding. You have to either remove the cap or like cut a part of the cap over here at the top and leave one that's merged with the whole part at the bottom. I guess since this is kind of straight over here, I can leave it over here. I can leave it merged. me cut this out like this. But there will be changes eventually when I start like organizing all the parts together in the UV editor over here. Run this to filter again. See where the part is. And there seems to be a problem because it doesn't work out. I'll just cut it all out and then later on merge it if everything goes well. Alright. Now we could probably open this up over here. This is where we did the hole, and we really want to avoid having holes inside a simple UV island. I like when things are uniform, and this one will probably be cut in half later on. Let's see which edge we selected over here. Select this one instead. Really, you want to place the seams where you can't really see them once you're in the game engine looking at a rock model. In this case, instead of having it like in the front in a flat area, it would be too obvious. So probably better to place it over here. And cut and run this to the filter through the filter again, the unfold filter. Okay. I could probably create another part here, as you can see. This one is important. Alright. And to deal with this one here that has a hole in the middle of it, so over here, we'll create some extra seams. I'll assign the straight shader again and see if you can see that we dealt pretty much with lots of stretching problems, but we still have some very red areas that needs to be dealt with. So we'll have to create extra seams again, but really it won't be that much. So in this case here, for example, we could probably like create an extra seam over here. And that dealt with a problem over here. This one here needs to be fixed as well. Okay, the seam at the top. Having blue areas like these, like green-blue areas, won't be that much of a problem. I prefer having more extra pixel density instead of having blurred out areas. This one will be fixed through UV editing, manually moving some of the UVs. create a cut here for this one. There you go. It fixed the problem. Sometimes it might be difficult to see where you want to create a cut. That's why I switch between the different shaders. Guess we could like go fully all the way. There you go. I think we pretty much dealt with all the problematic areas. We might need to cut some of these areas again and like cut them in half to try to optimize when we start organizing all these UV parts together and try to fill the whole UV space. Alright, let's assign the Lambert shader again and start working on the UV space. First of all, probably want to select everything and scale it up a bit. Set it to English, set it up to French. Generally, when you try to organize all these parts, you want to start first working with the bigger ones, with the biggest ones, and put them all together in a way where they use the less space and you have less spacing between them. So usually I like to first like scale it in a way where the biggest part like takes most of the UV space, but sometimes you don't want to go too high on this because you have to take in consideration the other parts. I'll just use this tool here to move shell tools and organize them in a way where the parts that are like let's say the medium parts, then you got the bigger parts, you got still first, and the smallest one they'll be put together in the end to fill in the holes between the parts. Now the priority would be first to deal with these two, then these three, and this one, and then we finish with the smallest one. Sometimes when you deal with UVs like these, especially when there's like lots of seams, it's probably best not to rotate them at all. That way, because the algorithm, what it does when it packs the UVs, they'll all have the same orientation. Let's say this one is orientated like this. The next part next to it will have the exact same orientation. And when you render your normal map, this will actually, if you don't rotate them and you just place them in a way together in the UV space, when you render the normal map, you'll actually have less seams. But if, let's say, I have this part here, let's see where it is. Go to shell. Okay, so this is the part. This part here, and this one here. So these two are next to each other. So if you render out the normal map, you're gonna have a set of colors that will tell you where the normal orientation. But let's say that the oriental orientation, the normal map turns green around this area, around this edge, and obviously it would turn green around this edge as well. But if you rotate around this UV shell, switch to default tools, sorry. This edge here wouldn't be green anymore, and it will have different color. No, actually it will be green. Technically, it will be green because the green is for the y-axis. Um, it will be this one here. This part here will be red, and this here it will be green. Even though UV wise, these edges should link together in this way. This one's supposed to be here, and this one is supposed to be here. So it's best to have like green showing up around this edge and green showing up around this edge when you organize your UVs, and that will help you avoid get less normal map seams. So be careful with that. But since I did the UVs in a way where the seams would be hidden by the ambient occlusion, so you could afford to rotate around these UV shells in a way where you could like fill out the whole UV space. But if you're like working with a hard surface model and you wanna have you wanna avoid having normal map seams, you really wanna have your UV shells orientated in the same way when you put them next to each other. But really, you could find a whole documentation about normal maps and seams and how to avoid them on Polycount. There's a whole wiki page dedicated to normal maps, and I'd suggest you to check it out and read the whole thing if you can, and it will really help you uh, decide, help you on the decisions that you're going to take when you create your UVs and how you can optimize them. I'll just run again the repack this whole UVs, and I'm guessing that I'm just going to avoid rotating the UV shells. That way we'll have a very clean normal map without UV seams, without normal map seams. So I'm just gonna scale this up a bit and move the UV shells, do really fast UVing. I mean, I could like spend maybe half an hour or 45 minutes, sometimes more, when you're working on when there's like lots and lots of parts that you have to deal with. Turn off prevent overlap, that way you can move with the UV shell tool without having the shell go back all the time to its place when you moved it. And even like this, we still have like lots of space to work with. Sometimes, really, it might be really difficult to fill the whole UV space. So in this case, if you're working on a game, well, you could probably organize your UV layout in a way where you can, let's say, I'm just going to use half the UV space I have here, and save the other half or the other quarter for another model. Let's say the same type of rock model but a smaller rock model, for example, and bring in the two models when I start making UVs, and the one has already made UVs, already done UVs, and start organizing the whole UV shells in a way to fill out the whole texture space, UV space that you have here. Now I could probably like scale up the whole thing a bit because I can see that still have lots of space that it could fill in. So I'm guessing that I can just scale up a bit and start figuring out how I can fit everything all into a single UV in the whole UV space. So I guess where I can fit these. That this one can be problematic. Even if it doesn't fit inside, you can just put it like this in a way where you find it that it is the best setup, and then just scale the whole thing just a tiny bit to fit it all inside the UV space. And we still have this chunk here to deal with. Don't hesitate sometimes to um, create new themes if you wanna still respect, if you wanna still like save texture, if you wanna fill out the whole texture space. So you just, for example, this part here really doesn't help. I mean, you really want to have a uniform like UV shell. Sometimes cutting out some parts and creating extra seams could help you out. In this case, for example, well, the seam could be justified. In the end, I'll still have to scale down the whole thing. So I'm doing these UVs in a way where uh, I'm not even rotating the shells at all to avoid getting extra normal map seams. Especially when you're dealing with an engine such as UDK, you really want to have the normals be uniform on the whole texture. to turn on the toggle shaded UV display. That way you can see if there are any overlapping UVs. We definitely want to avoid that. That way we won't have any problems when we render out normals and ambient occlusion. And try to give it some space and some air between the UV shells. That way it's better for texturing. Usually they'll appear when you overlap two UV shells. They'll show up like this, or sometimes there's an option to make them show up in red as well. It doesn't matter at the moment. We can definitely see it directly. And make sure also that all your UV shell are inside the square UV space. Right, I'm gonna do one last check with the stretch shader. And do some fixes really quick. I'll just go to UV mode and move some of these UVs manually while having straight shader on. Try to have a more uniform green going on. This is very similar to the relax operation that we could automatically do, but I'd rather just do it manually. Because I can have direct feedback of whatever shaders do. Alright, I guess the job is done with the UV. We can save the project and make sure that we don't lose everything in case there's a crash. Save scene as. Okay. Reassign the lambda shader again. And we're gonna use one single smooth group for if you guys use 3D Studio Max. So in order to do that, just in Maya, just go soften edge, and there we go. In 3D Studio Max, just use one smoothing group for the whole mesh. Since this is an organic model, you don't really need hard edges, because unless you get a very, very hard edge on your mesh. Now, I'm guessing that we're done here. We could probably start doing our first test renders in Xnormal. Make sure to save your project. I'm just gonna check the time quickly here. Okay, so we got enough time to do some rendering in Xnormal. So we'll export this as an obj. In the rock tutorial folder, and we'll name this rock underscore 01 underscore UV'd, just to make sure that this one is the mesh that's going to be used. And I forgot to add the underscore LP. There you go. So this is the final low poly mesh. We'll export this. Now that we have the high poly mesh and a UV low poly mesh, we can run Xnormal. For those who don't know what Xnormal is, it is an application that allows you to render out different texture maps, such as normal map, height map, ambient occlusion, cavities, and lots of different and fancy stuff. It is a free application that you can get from xnormal.net, and I'm using the latest version at the moment, which is 3.17.13. Now, what we first need to do is go to the High Definitions tab mesh. I'm just going to clear this out. Usually by default you get this window like this. You just right click over here and add mesh. All we have to do then is, later on, is just browse to the where we save the high poly mesh. This is the high poly mesh I'm going to use. This is the one that I exported from 3D codes. Rock underscore 01 underscore 3DC underscore HP for high poly. Just open. Okay. Now once we're done importing the high poly mesh, you just go to low definition mesh, and this is where you're going to tell it where the low poly mesh is. The low poly mesh, if you remember correctly, is the one that we UV'd here in Maya and exported as rock underscore 01 underscore LP underscore UV.obj. So you open this up. At this point here, we're done importing the meshes. But before we start baking the normals and ambient occlusion, we probably want to run this to, you go to the Tools tab and run this to Ray Distance Calculator. So this is going to calculate the values that you want to enter later on in the Low Definition tab here for maximum frontal ray distance and maximum rear ray distance. So technically, if you think about it, since we're not using a cage for rendering the normal and ambient occlusion, this is going to give you the optimal values for where the cage is going to be pushed outside and the one that's going to be inside, in order to capture all the detail from the high poly mesh. So we go to Tools, Ray Distance Calculator, and click on Go. And let it run for a few minutes. I'll pause the video while it runs. It'll run for like 2-3 minutes, and it will give you the optimal values that you want to take note of. And these values are going to be changed over times, and it will keep on computing. Once you're happy with the values, just press on stop, and you'll use those. Alright, I'll pause the video here, and we'll be back in a few minutes. Alright, now that we're done doing the ray distance calculation, it gave me a value of 6.2, 18, and 8.114. So you click on stop and note these values on a piece of paper or on your notepad. I'm just going to put these here. Alright, you could also copy results directly if you want, which is a new feature. And if you click on copy results, it will automatically put them in there. Now we're done setting up the ray distance. We will just have to make some view settings, and we'll first set it up to render out a normal map. The size, well, this is the size of your texture, the output texture. Here, if you click on the 3 dots, this is where you're gonna define where the texture is going to be saved. So what's cool about Xnormal is automatically when you just put down a name, in this case the asset in question is named rock underscore 01. Just name it rock underscore 01, and if you render a normal map, it will add an underscore on M, which stands for normal. If you do you render out an ambient occlusion, it will add a rock underscore 01 underscore 80, which is really handful. So you click in the options for your normal map, and here in this case it's set up to render the normals in X+, Y+, Z+. For if you're rendering a normal for UDK or Cryengine, you probably want to set it up to minus. This is pretty much for the channels of your texture. But really, at this point, it doesn't really matter if you set it to y plus or y minus, because even if you use the default values, you open up your normal app in Photoshop, you can just invert the green channel and have it correctly render in UDK or Cryengine. So I like to leave it at a y plus because Maya uses a y plus for rendering normal maps. Mudbox does the same. Bunch of applications such as I'm not sure 3D Studio Max. You get the options if you wanna invert. You import the normal if you wanna invert the green channel or not. But I like using Y plus for everything, for all these assets I have. That way everything is all uniform, and I already know that my normals are all set up in Y plus. But this is mostly a personal preference. You can just set up to Y plus or Y minus. It's all up to you. Leave it to Z plus and leave it to X plus. Tangent space, you have to have the options, this option on, because this is how the most game engines render normal maps. Now, edge padding is for where, for example, it'll add, let's say, 2 or 3 pixels, and it will stretch the normal, and it helps you avoid having extra seams. If you have this value set to 0, you might get some black seams on your normals. So put a value of 2 or 4, really depends on the resolution of the output texture. But a value of 2 or 4 is good. You could 3, but don't leave it at 0. If you want to use 0, usually you use 0 if your texture is just uses the full UV space and it is just you're rendering out a texture, a tileable texture, for example. You could like leave it at 0. It won't be that problematic. The bucket size is think of it as if when the processor, if you're using the default bucket renderer, the processor splits your texture map in different squares, and these squares are the size of these squares are defined by the bucket size. And if you have, let's say, a Core i7 that uses hyper threading, it will divide the task in 8 squares of 64 by 64, and it will calculate each of these square on every thread of your on every core of your processor. Well, I'm using hyper threading, so it's going to be divided in 8 pieces of 64 squares. Well, you can do some tests depending on the processor you're using and see which is the optimal bucket size for your processor. So usually a good value would be 128 or 64, but if you're using OptiX CUDA, which is based on your GPU renderer, it renders faster. Well, the bucket size in this case, I don't know what happened since I did a fresh installation of Windows 7. Doesn't show up the anti-aliasing and the bucket size are off for some reason. So I'm just going to stick with a default renderer. This is based on the CPU. It could be slower. It's slower than the GPU renderer for rendering normal maps and ambient occlusion map. Problem is when you use the CUDA renderer, the OptiX CUDA renderer, cavity rendering won't be available for you. You only have normals and ambient occlusion. I haven't tried the other options yet, but I'm sure that normals and ambient occlusion work, and it is extremely fast if you use the OptiX CUDA renderer. Few things that you need to keep in mind if you want to use the GPU-based renderer is that you need lots of GPU RAM, GPU memory. In my case, I have a NVIDIA GTX 285 GTX, which has 1 gigabyte of video memory. What the GPU renderer does, it actually loads the high poly mesh onto the video memory. And if your high poly mesh is really high poly, like 5 million polygons, let's say, the GPU renderer won't be able to render your normal map or ambient occlusion map. I'll be right back. I have to answer the door. Sorry. Okay, so I was saying that long story short, if you plan to render out your texture maps using the GPU-based renderer, keep in mind that you'll need lots of video memory. So a minimum of 1 GB of memory if you want to render out meshes that have like a bit over 2 million polygons, high poly meshes with over 2 million polygons. So in this case, I'll just stick with a default bucket renderer based on the CPU, and I'll set the edge fading to 3, 4, say. Um, Texture size 2048 by 2048. I like having high resolution texture because when later on, if I want to bring it into game engine and when you work in the team and you decide on a texture budget, you'll have the possibility to resize the texture down and you'll still have the high resolution texture just in case you want to do major changes to it. So always work with high resolution textures. So we'll check the normal map. We'll turn the anti-aliasing all the way to 2 times. You could go to 4 times. Normal maps render really fast even though you render them on the CPU. Naming has been done. And all that's left now is just click on generate maps and wait a few minutes until it's done rendering. So I'll pause the video until the rendering is done. Alright, the rendering is done. It rendered the mesh in around the normal map in around 31 seconds, which is pretty fast. We'll do the same thing for ambient occlusion and cavity. So in this case, you probably want to turn down the anti-aliasing all the way to 1, because ambient occlusion does take a lot of time to render. We'll go to the default distribution is set to uniform. We could probably try out different settings. You got different algorithms for rendering out the ambient occlusion. Think of it as cosine and cosine SQ. You'll have less fall off. The shaded area will have less fall off. It will be much more retracted towards the cavities of the mesh. Uniform, well, self-explanatory. You have actually the distribution on it, the description on it. Uniform will gives you more uniform shading for the ambient occlusion. So cosine will result in much darker cavities than uniform. You can test out with these settings and see which one fits you the best. I'll just stick with uniform. And the spread angle by default, I think it was set to 160 degrees. I like setting it to 145 or 140, but it really comes down to tweaking and testing out different values and see which one fits the best for you when you do the texturing. So with 145 degrees, the spread of the occlusion, the shading will be less larger. It will be much more retracted towards the edges. While higher values, the occluded area would be much larger. So other than that, all the rest is just default values. Just leave it the way it is. The rays will define the definition or the precision of the ambient occlusion renderer. Higher amount of rays will result in slower rendering, but much more cleaner ambient occlusion maps. The default value is 128. 256 is good. 512 is for really final rendering, and it takes much longer, but you get really clean results. So I'll just leave this to 256 rays. I think it's a good compromise between quality and speed. But really, if you're working in a game studio and you have really high spec computers, or if you're using the GPU-based renderer, you could use a 512, and it will still render really fast. So I'll just leave it at 256 as I'm using the CPU-based renderer.
Okay, now all I have to do is just press on generate map and wait until it's done. So I'll pause the video here. Alright, it's done rendering the ambient occlusion map. Took around 200 seconds, which is about a minute or two. No, 2 minutes or 3, sorry. Um, Now, once we're done doing the ambient occlusion map, we're just going to do the same for the cavity again. We'll check out the settings. So, you really don't have that many settings to change anyways. Um, I mostly focus on changing the rays, the amount of rays. The default value is 128 again, so I changed it to 256. Higher values will give you a higher quality. What a cavity map is, think of it as an ambient occlusion map that mostly focuses on the very defined detail, like the very small cracks, and it'll help to define those and gives you some shading on these areas, while the ambient occlusion really focuses on the large details, but you can still set it up to render some medium detail as well. So cavities will capture for you all the very small cavities and cracks, and really helps you get extra detail. So I'll set this ray, the amount of rays to 256, and don't turn on jitter. Sometimes it's preferable if you turn on anti-aliasing to 2.1 or 4 if you can afford the time rendering rendering out a cavity with anti-aliasing. Uh, Sometimes rendering out a cavity map at higher resolution with anti-aliasing set to 1, let's say at 4096 by 4096, and then later on resize it to 2048 by 2048 in Photoshop. You'll still have some anti-aliasing done, and sometimes it could be faster than doing anti-aliasing, turning it on. But in this case, I'll just use a value of 1 for anti-aliasing and leave it 2048 by 2048 for the sake of the tutorial. Um, Make sure that the others are unchecked and just render out the cavities. If you really want to speed up the process and avoid like having to check and uncheck these these rendering options, you could just do everything in one single pass and render it out and wait like, I don't know, 5 minutes, and renders out everything for you. But anyways, check the cavities and do again. Click on generate maps and wait a few minutes until it renders the texture map. I'll pause the video again here, and I'll talk to you guys later. Alright, now we're done rendering the cavity map. You'll probably notice sometimes that you'll see some dark, some black spots on your texture map. Now that's where the ray misses occur, because we didn't really set up a cache for it in Maya. We just quickly did one to ray distance calculation in Xnormal. Now you got two solutions to fix this. You could either go in Photoshop, open up the texture, and use the smudge brush or the clone brush and clean up and remove all these dark spots because they will look terrible in your texture map in the final texture map. Or you could render out the same texture map again with different ray distance settings when you render it out. You just, instead of using a 6.2, 8.1, you could use a 0505, and then use it as a layer in Photoshop and apply a mask texture where you can just paint where the areas need to be fixed. Like, let's say for example, the 0.5 maximum ray distance and rear distance cavity map won't have these dark spots in these areas. They'll probably occur somewhere else. So there are these two methods to fix this. There's a third method actually, which is very simple. You could, instead of using the ray distance calculation tool, you could just create a cache in Maya and export a cache and use it in Xnormal, because you have the ability to import an external cache. Browse external cache, you import that, and you're done. You just render it out, and you shouldn't be having any issues in your texture maps. But anyways, now that we're done doing the cavity, normal, and ambient occlusion, you probably want to render out an edge highlight map in Mudbox. There are two ways of doing this texture map. You could either go in CrazyBump. For those who don't know what it is, well, I did buy this application. I bought this application at the moment. I'm just, since I did a fresh reinstall of my computer, I still haven't typed in the code, activation code, but you get access to a 30 days trial with a fully operational software. As you can see, this is the evaluation version. Now, first what you might want to do is go to your renders folder. You should have 3 texture maps. You want to open them up in Photoshop. I'm using Photoshop CS3. Bring them in Photoshop and check if there are any problems or any cleanups that needs to be done. So this is the ambient occlusion. I think that the ambient occlusion map is clean. I don't think there are any problems regarding this texture. It should be the same for the normal map as well. So yeah, as you can see, the ray distance calculation with Xnormal really helps. You don't really need to spend too much time making a cage. Usually, you probably want to make a cage for very complex models that have complex topology. Let's say a mesh that has a hole in it or something, or hard surface models most of the time, where you really need to set up a cage and to fix some of these normal map seams that will occur later on. Now, as for the cavity map, I don't think they'll need to spend time rendering another cavity map with different ray distance values. I could just probably like clean it up really quick in Photoshop. The clone brush really, I think, does the job for it. And when you zoom in, you really notice that having higher ray amount of rays and anti-aliasing will definitely help to get better texture quality. This is really mediocre quality in my opinion. I'll probably render out another one with higher resolution. For some reason, I did a bunch of copies of the same texture here. Alright. And really quickly clean up and remove these dark spots with just a clone brush. And I'm not, if you have the same problem with the ambient occlusion, they usually show up as white spots instead of dark spots like these ones. You probably the best tool would probably to use a smudge brush with a 50% strength instead of using the clone brush. Okay, we can save this result here. Just Control S for Control Save, and save as the TGA. This one is cavity. There we go. This is a 24-bit because by default it comes with an alpha map. Could be useful if you're doing your whole texturing in Photoshop. We could use this as a mask, for example. Okay, since we opened up the normal map in Photoshop, I'll show you how to create an edge highlight map with CrazyBump instead of rendering one in Mudbox. What do you need to do first? Usually what I do, you could either open one normal by just clicking on this icon, or you can just select all and copy, and the option also, I'll just press normal map from clipboard. When you click on this, just need to wait a bit to give it some time to process the normal map. You just select the box preview. Alright, now the goal here is to pretty much extract this diffuse texture that shows up, which has some nice edge highlights generated from a normal map. If you go to the diffuse tab here, this is the texture that we'll use for an edge highlight map, and it also has some cavity information which is which is dark here, as you can see. Um, what I usually do, I just push the sharpen slider all the way to the max. That way I can emphasize the edges over here, and then turn on the 3D highlight options. I don't know, to value of 5 or 10 if you want to really emphasize the edges. Value of 5 is good, in my opinion. And remember, this is all done in the diffuse tab. And once you're done doing these changes, just right click here and copy diffuse to clipboard. Wait until, and it is important when you do a copy diffuse to clipboard, wait until it's done loading. Otherwise it won't copy it if you switch to Photoshop. Then go to Photoshop, create a new document. It will automatically set the size because you have a document that is saved in the clipboard. And you just Control V to paste the texture. Now this texture here could be used as an overlay on top of your color texture, and it will help you define the edges of the rock and some of the cavities. So this is one way of doing an edge highlight map which has cavity information. So you could save some time. Instead of rendering out a cavity map in Xnormal, you could just skip that, render just a normal map in ambient occlusion, and use your normal map to render out an edge cavity map. So I'll save this texture as a TGA in the renders folder. Name it rock underscore 01 underscore edge underscore cavity, and save it. Okay. Now we'll look into the different way of rendering in a highlight map, an edge highlight map. Remember, we already have a cavity map that was rendered from Xnormal. I'll show you the rendering method, which should give you much more accurate results and sharper edges, which might look much better, higher res on your mesh. So you don't have the ability to do it in Xnormal, so you'll have to use Mudbox to render this texture map by changing the view settings in the ambient occlusion tab. Now what we're going to do here, we're just going to import the low poly mesh and high poly mesh, and the high poly mesh is still the same here, the rock01 2DC underscore HP. We'll just open this up. You're gonna get an error message. It's gonna tell you that there are T-shapes in this mesh, which means that there are no manifold topology in it. This is because we exported this mesh from 3D code, which was a voxel object, and obviously you'll get some problems when you use if you wanna use this mesh for sculpting, for example. Reuse it for sculpting in another 3D package. Well, in this case, the actual mesh is still usable. You can still sculpt on it, but you cannot subdivide it, which means you cannot add more definition to it. And you can also extract texture maps from it, use it as a high poly mesh. So we'll just keep all, and it'll tell you that you cannot, even if you try to subdivide this mesh, it'll tell you that it cannot subdivide it because there are no manifold geometry in your mesh. Now, once you zoom in, you'll see that it is actually quads, but sometimes some of these areas, for example, a non-manifold geometry, let me find one for you. Usually they'll appear around the edges between in the cracks. Could be difficult to find sometimes, and this is here a good example of non-manifold geometry. You got T-shaped faces, which means that there's one edge, and you got three faces coming out of it, which won't work if you try to subdivide this. So if you really want to subdivide this, you'll have to run this through some cleanup filters in Maya or 3D Studio Max. but this mesh is still usable in a sense where you could still add some detail on it and use it for rendering out texture maps. Okay, now we're going to import the low poly mesh. You just go to File, Import, and import the UV version, of course. And there it is. Make sure that you name these objects, that way you can recognize which one is the high poly mesh and which one is the low poly mesh. So the volume 5 is the one, the voxel based object, and it kept the name from the 3D code, so we can pretty much guess that this is the high poly mesh, and we just name it to HP, that stands for high poly. And the mesh here, which is the low poly, we'll just name it to LP. Now all we gotta do is go to Maps, Extract Texture Map, New Operation. Select the ambient occlusion by checking the box here. The options will load up automatically. Select your low poly mesh and click in the target model. You gotta, it shows that it is for the low resolution mesh. You click on As Selected. Select now your high poly mesh and click As Selected here in the source models. Now in order to render out a edge highlight map, you have to change the filter value to a negative value. Instead of using 0.01, we'll use a minus 0.001. This will, instead of rendering out an ambient occlusion map, it's actually going to instead of highlight the edges on a texture map. So you'll end up with a black and white texture map. You're gonna get pure black and pure white values. Sometimes you're gonna have some. You're not gonna have any gray values into this texture map. So it's really useful if you use it as a layer in Photoshop, as a linear add layer to highlight the edges on your color map. The image size, you need to set it to 2048 by 2048. Same for the shadow map resolution. I like using anti-aliasing for this kind of texture, but sometimes really you don't really want to use it. It might take too much time for you. It really depends on the kind of quality that you're aiming for. I'll just let this off for the sake of a tutorial and render this map real fast. Change the method to ray casting, and quality good or best, up to you. I'll just leave this to good. Map texture output, leave it as texture. Just disable previous diffuse, that way we'll avoid reprojecting the texture on your high poly and low poly mesh. Then you just set up where the texture file is going to be saved, and since we're doing this, we're saving all our stuff on the disk, which is on the folder, which is on the desk. We'll just put this in the renders folder and change the type of file format to DGA and rename this as rock_01_edge. Save this, and once you're done doing these settings, you could probably do best guess for the search distance and turn on test both sides. This really needs to be tested out. I think that a value of, I don't know, 15 could do. But try a best guess and see which one works the best. And if you get any errors showing up on your texture map, you probably want to increase these values. If you get any rays that are missed, sometimes they show up. Well, in this case, you won't be really able to notice, since most of the texture is going to be all black. But if you're rendering a regular ambient occlusion map, sometimes you're going to get empty spots, and this is where the rays are missed. So you might want to increase the search distance. Well, you get also a description that shows you exactly what it does. So it's fairly simple to understand. I'm just going to use a value of 52 and let the best guess do the job, and click on extract. Leave the rendering should take around, really, if you turn on anti-aliasing, that's really going to pump up most of the time. Rendering time is going to increase exponentially. Instead of taking like 2-3 minutes for rendering a texture map, it will take you like 15 minutes or maybe higher. and it'll make your computer completely unusable during that time. So be careful with the anti-aliasing settings. So if I'd suggest instead of turning on the anti-aliasing, increase the texture resolution and then downsize it in Photoshop in order to get some of that anti-aliasing. It might speed up the process and it might be faster for you. Anyways, I'll just pause the video and wait until the rendering is done. Okay, the texture rendering is done. We want to check out the texture map that we rendered out from Mudbox. Now if you zoom in, as you can see, it captured only the edges. This will help you emphasize the edges on your rock and give you a nice erosion feel on the texture map. And if we compare the texture map we got from CrazyBump, let's copy this. First I need to make sure that the mode is set to RGB in order to bring this as a layer on this one here. This one also is set to grayscale. Alright. Now if I zoom in and check out the edge here, you can see that the texture that comes from Mudbox is way more refined, and it's kind of really, you get nice fine detail here. Problem is with CrazyBump, you get really blurred out edges, as you can see here, and it's really can have a bad hit on your final diffuse texture and make your texture, even though it is like a 2048 by 24 texture, look like a 1024 by 1024 texture. In this case, it's probably best to use this if you are planning to downsize this texture anyways. I mean, you work on a 2048 texture and then you're going to downsize this to 1024 and use this as a 1024 by 1024 texture in the game engine. So sometimes I would say, if you really want to use CrazyBump for getting this kind of texture map and want to save some time, you probably want to render out a very high resolution normal map. Let's say, for example, 4096 by 4096 normal map. Render out, generate this kind of texture in CrazyBump, and then downsize it to 2048 by 2048. So the one that you get from Mudbox is much more refined, even though it has a bit less of detail, but much more refined and much sharper, as you can see here. Plus, the one from Mudbox doesn't have the cavity information, and you get the ability to use the cavity map. It comes from Xnormal, which will be, again, more refined than the one you get from CrazyBump. So when we'll start doing the diffuse texture, because let me see the time here that I've been recording. I got an hour and a half. So I'll be stopping the video here and finish this part here and call it part 2. In part 3 we'll be doing the texturing in Mudbox. I mean, all we're going to do, just to solve this, we're going to do the texturing directly here in Mudbox and set up the layers just like in Photoshop, because you have the ability to set it up exactly in the same way and directly use a stencil image, a rock texture, color a photo source rock texture that I got from cgtextures.com. Use this one for instance, and directly start painting on the model and have it some sediments showing up to, and then later on render out a normal map from the color map and get it some extra detail. Anyways, I'll do all that in the third part of this video series. Thank you for watching. So I'll see you in the third part.